Hello everyone, welcome back to ROM hacking with Stewie. It's been a while since I posted the video. I was busy and yeah, so I wanted to do some video again about Super Robot War Z. As you know, we have a fan translation project going on at the moment. So I just wanted to have some fun with the game, doing some hacking, and show you a few things we can do with ARMIPS. So the the use case for today's session is basically we have some. Let me just to zoom it. We have some translation that we did for the search menu. So this is when you're here. Let me just go back. You go in the command menu, search, and you go in the spirit. Don't focus too much your attention here. There's a lot of things going on. What we want to do is we have these translations that are added recently for the spirits and their spirit command and their description. Here the English is okay and the font is accurate, so our variable width font work properly. But these translations they are also used in a different menu. Let's say you select a pilot like a unit and you go under spirit, you will see these spirit translated here, but as you can see the font it's very squish and like here. So this menu requires some hacking on it. So we'll want to do some hacking on this menu using ARMIPS, so to ingest some code, so to update some code and adjust the font here. In order for you to understand what we want to do, we'll just go back to what we discovered in older session of Robot Wars. If you recall, I've talked a little bit about a function that we discovered that is used every time the game needs to draw a specific string. It will call a function that I've called it set text properties. This function receives a parameter, and then depending on the parameter, it will copy a series of attributes in a specific place in memory. And this is basically how the game decide to the size of each character. So if we try to do something like this function, I'm not even sure if I have it mapped, but let's go maybe under the weapon, I guess, weapon info menu, just to show you how it behaves. So I have I have a few functions about the weapon menu. Let's try the info top or left, meh, info stats, something like this. Let's just find one function like this one. So when I click on it, I see it on the left side with the assembly. And if you recall, the first parameter in assembly for PS2 is always the A0 register. So we just want to look for A0 register, and we find it here. So I guess it's param1, but it's actually like when you go in the definition, it will tell you it's A0 param1. So but yeah, so I guess it's param1. We need to have a look, and we see this is where we store the value for this parameter. So it's a load instruction. So we can go at this address in memory 39. Let's go in the debugger. I'm using the the nightly build for PCA62 debugger, which is quite impressive. There was an update recently and it added some interesting feature. 39, 28, 5C, 39, let's go 39. So when we jump to this place, we see I actually have 13 because this is the patch version. Like this is the translated version. The Ghidra is loaded on the original code, so that's why we see 4. But I know if I update this 13 and I look at the game, this will update one part of the game. So let's try 0C. So as you can see, it's changing the text here, and I think it also updates the one over here. So yeah, so the space, the font, and what you can also see is depending on what I put here, my variable with font is not behaving properly. Like it's a lot more squish, and even like you see the U, and this is because I've I've established the variable with font to only work on 4 different parameters for this function. So I have 0C that I know worked, and I have a table defining the width of each character. I have the 13. 13 is my smaller version, like the smaller font I can use in the game, which is pretty useful when you don't have a lot of space. And I believe I have 00, which is a biggest font. Let's say for the command menu, this I usually use the 00. So it's not perfect, but it does the job. Um, so yeah, so basically what we need to do, like we said, we have our spirit, spirit menu here, or pilot menu, something. We need to find the function that is used to draw these strings, and we know we'll have to change the font here to probably use the 0C maybe, or the 13. This one will need to be adjusted. We'll SP also probably the name of the pilot, because if it's translated at some point, it will also need to be adjusted. So let's find, like we know the will is something that is used in a lot of menus. So if we just try to search for will in the memory, we will have a lot of match. So let's see, just to show you what I mean, we go in the memory search in the debugger. I'll use string since we know it's ASCII string, so the emulator supports ASCII, so English strings. So I will find probably, not too bad, not too bad. I was expecting like 12. So we have 3 different match where this string is translated, and you see like this one doesn't seem to be what we want. Probably not this one. So I would say the first one is probably this address is probably for this will. So let's try to test it. How can we make sure? We go to this address and we update a few bytes. So if we click on the right side here, we can input English character directly. So let's try to update the W for a F. It seems to work. We have a F here. So we confirm that this address is the string that is drawn on this menu. So now we want to find the function in assembly that is used to draw these strings. So let's put read. I can copy the address and create a new read breakpoint. if I create a new read breakpoint on this address, the code here will stop every time it will try to read from this address, so the one 43, 53, 46. And we see it's already stopped because it asks me to run. So it tells me it stops here, right here. It stops because it's doing a load byte operation, and a load byte is always it's always loading from a register. So load what we have at address A0. If it's a load byte, it will only load one byte, like the first byte that is at address A0. A0, we can go over the register. A0 is here, always just VU 43, and we see it's the same address. So we confirm that it's really doing it's really reading from this address in memory. The 0 is just like a offset. So if you would have 010, you would do what you have at A0 plus this value. This would be the address from where it's reading from. But anyway, this function 3A9770, we can have a look in Gedra to see what do we have here. It doesn't seem super interesting, and I already know, let's say from my past analysis, that this is not the function that is used to draw on screen. So maybe it's doing something else. We could have some fun also and use Copilot or ChatGPT and paste that here. So let me just try to do this. Maybe let's go. I have a few stuff. Let's do. I have this one should work. Copilot or ChatGPT are very good sometimes to give us a glance of what is doing. Okay, so it reads data and it seems to copy into a buffer. Interesting. How can we confirm that? Let's see. Yeah, well, just here we see it's loading and it does a store. SB is for store byte, so it loads into V0. V0 as our byte, and later on it will store into S0. Okay, interesting. Let's keep that for later. For now, if I hit run, I will try to see if another function or another instruction is actually loading or reading from my memory. 1A0C20. I can have a look also. If I continue, I will have my function 13A390, and I know from past experience, I know this is the function that is reading my string and drawing on the screen. So this one is the right function. But I want to know what's the, let's say, which function is calling this one. So I will remove my read breakpoint and step out of the function. So if I step out one time, I arrive here at 34 C5 64. Well, 34, this function is more like a wrapper on top of it. It doesn't, you see there's no, it doesn't do any set text properties, and this is what I'm looking for. So I will just continue and another time. 38 4B until I arrive here. So we have this function. So this is what I'm looking for. I'm looking for a function that will be having an address in memory. So if you go here, you see that this is the wheel in Japanese, and the address is different because when I reinsert my English, I have my own Python that reinsert stuff and update pointers. So that's why the address is different, but it's actually this function that will be drawing the wheel string. And if we go above, we see that there's something that is updating the color, and we have our set text properties. So if we want to confirm, we can try go to this function, and we see A0. This is the parameter. So if you recall in MIPS 32 and other architecture, there's always a slot reserve for when a function is called. So JAL will be what we'll be calling set text properties, and it will always execute the instruction right after JAL. It's something that beginner don't know, and even me when I started, you've discovered these things. So it's really this instruction will set A0 to 9, and then it will call set text properties. So 38 4B 2C. Let's go see what we have here. Let's do 4B 2C. It's at the moment it's 09, which is the what we saw. Let's put it here 09, and let's try to put I said my variable with font work with 0C and 13 as parameters. So 13 is the smallest one. So if we try, we see it doesn't change anything because we are still debugging, and I need to hit run in order to have the game continue running. Uh, we see, yeah, we were changing the fill, and you see now it looks better. It should be will, of course. So we can just go back and we put W. And we also confirm, I lost, what, 34, no, I think I used the 2, 38 4B2C. What is cool is you can use a second memory view. So sometimes you want to keep a string and have update parameters, and that's pretty convenient. And just let's confirm, yes, it's also updating the SP at the same time. So two birds, one stone, we like it. We could do, so now if we want to have a look at the persist spirit command, there are a few options. If you look at that, I already put a name for this function, and I think there are a few others. So yeah. So what we see in here is it will draw some texture, draw texture, draw some strings. So here it's the same string, yeah. So depending on the context. And there's only one call for set text properties, and we already saw it doesn't do anything for our persist. So let's do the same thing. We need to find this persist in memory and see which function is reading from there. We have to it. This one is probably not the right one because it's used, I think, in another spirit command. So this one might be better. Let's see, let's see. Let's confirm if it's the right string. Let's put the E majuscule. Yep, you see it's updated. Let's put a breakpoint. Read. Okay, it seems to stop at a very similar place. We will find the 13E3, remove the breakpoint, and we step out. I know I will need to do twice, so 3851. And I find another function which I called another name. So here, when we step out, it's this function. Okay, what we see is this is bon. Okay, this is very. It's a little bit different than the other one, but there's like a pointer table, and it will use an index on that table to have the address. But it seems to be this function, and we have a set text color too, something like that. And if we go above, we have set text properties here that might be responsible of what's happening here. So let's try to update this one in 3850 before. 3850 before. We have 04. Yep. Let's see. I always like to put the game on the right like this. I need to stop the debugger. I need to come back to the game. Okay, it seems to work. I don't know. So the challenge we'll have now is depending on the size of the spirit command, I will probably prefer to use the 13 because some spirit command name might be very long. So using the 13 might be the best option. But what we also confirm is that the text is not super aligned with the rectangle. Like vertically, it's not that great. So we'll probably have to do a few things here. So now we are at the point that we did two modification. We're able to do two modification to update the font. And we know we had to update two different places in memory. We have only did it in memory. So how can we integrate this into our patch? Every time we will want to create a new patch, we will want to allow to redo these modifications in the code. And this is where ARMIPS comes into place. Let's have a look at ARMIPS. Let me just open a few things and I'll be back. So, in my folder, I have my folder for Super Robotoirs Z. I have a few ASM file for assembly, and all of these they are called by ARMIPS. So ARMIPS is a executable that is run in command line. And in my process, at the end, I will be running ARMIPS to update some binary file, basically. So I will show you how it works. So let's just see how can we let's just look at one specific file. So the what I have right now is I have one file for each menu. So everything that has to do with let's say the command menu, I will have one ISM file, and this file will open the binary file, and it will go to specific address. So each of these address is the in-memory address or the address we see in Ghidra, and we will replace the instruction by a new one. So if you look, 0C is actually the A0. This is exactly an example of a function where I had to update the text size. So I will have a bunch like these, and we can put comments to understand, like this is for when the game will be saved, prompt, blah blah blah. So adjust Y alignment. So I try to have a lot of comments because you never know when you have to come back and edit these. Um, why do we use ARMIPS? Also, it's because, as you can see, I'm able to write assembly code, and ARMIPS will be able to convert this instruction and to update my binary file for me. Because imagine if you have to go in a X editor and update bytes and then save your binary file and load it. Yes, you can do that, but you will have like I have 12 file like this. So imagine how many change I have to do to my binary file, and if something crash, you with just a binary file, you don't know what was changed. I don't know this byte. Is it responsible for the size or it's something else? So it's this RMIPS is very important for when you do remacking for all console because you can do PS2, 64, PS1, whatever. And it changed my life when I use it. So yes, if you ask all the remackers what they do assembly hack, they will all answer RMIPS. It's the tool to use. So let's do a simple ARMIPS file in order to do our two change. So I will just copy the same information that I have here. I need to open and close my file. It's always stuff I need to do. This will open the SLPS file, also the executable file. If you remember, this is what we loaded in Ghidra. It's the SLPS, which is the main executable. And this is the address of where the SLPS file is loaded in memory, which is also something we did in, I think, my first video. So let's do, this is to update wheel and SP position, text size, and this is to update, so my column is for a comment, so this won't be executed, it's just for documentation purpose. Update spirits size, command size, text something like that. And now I will go back in Ghidra and just we can do a few things. So I know this has to be updated for our spirits, and I just want to copy this operation. So I'll do this, and I'll just copy here, and you'll see. No? But yeah, so you can just copy this here. So this is in hexadecimal. If you want, you can remove the double zero. And we don't need these bytes. I will just use the li command. And I like to do, I go back here, do one tab like this. Sometimes people will put the dollar sign in front of the register. It depends on people, but ARMIPS is able to do the operation without the dollar sign. So up to you. And what we wanted to put there, we said for the, we said this was for the spirit command. So this should be here, right? Oops, and I will just save it just to be sure we don't do some stuff. Let's call it menu spirit, I don't know, spirit choose, spirit pilot choose, something like that. Choose spirit, whatever. So here, let's go back to where we add the wheel and SP text stuff. I believe we have to go in the mid tree. Yeah, it's here. So usually once you test and you confirm it works in game, you already go in ARMIPS and put your command so you don't forget about the address and stuff. So it's just it would be the same operation but different address. So I will just change the address. Maybe there's a faster way to do this. I'm still a newcomer in terms of remacking, so but this is how I'm doing it and it works. So okay, so now the idea is this ARMIPS. This is a parameter. So when we run ARMIPS and command line, I believe we could try in here. Yeah, let's try that. Maybe probably it will not work because I'm doing a demo, but you never know. Let's grab a SLPS file just to show you what it will do. So let's say I'm taking the original SLPS file. This is the name of my file, and I can open a command line here, and I can, since I already have ARMIPS in the same folder, I will be able to run ARMIPS like this. And I believe I will have to usually I have my Python that is running this. I can show you how it behaves. Oops. So but my Python process as when it does the insert, guess it's is it the older version I'm using? Ah well, I have this patch binary that looks like this. It uses subprocess module to call our MIPS. We pass main ISM, and then we need to specify our parameter. So this is the equivalent of trying to do our MIPS, the name of our ASM file, which was menu spirit choose ASM. We pass the SLPS path, and we need to specify this string equal with the name of our parameter. Since I'm in the same folder as my file, no, not this one, okay, I am in the same folder, I can just paste the name of the file like this. Okay, I have a good typo on the spirit. Let me just confirm the name spirit choose. Okay. And then it seems to work, and we have our file. You see it has been updated. So the instruction, both instruction has been updated at this address. How we can confirm is we could look in the SLPS, but remember, if we look in the SLPS, we'll have to remove the offset of where the file is loaded. So if it's loaded here, I will need to take this address minus this. I like to use Python for that. I go in the console, and in the console, like when I'm opening a Python console, we can do 38 4b to c minus 0fe 580, and we can convert to x like this. And then I can go in my file and see. So the equivalent address in on disk would be here, and we see it's not updated. That's interesting. Hmm. 38 4B, did I do a mistake? Maybe. 38 4B to see if just think. Let's just confirm the bytes if they make sense. But okay, the other option is the maybe the file has not been updated properly. Oh well, okay. I'm probably missing something, I guess. But the easiest way is to just run my patch and see if the change are there. So we can do this. I just need to add my new file in my main ISM. So I need to include my new file so that it's now integrated. And we'll see if it doesn't work. We'll see it. So let's do pack all. So this will create for me a new build, and then I can go and see if my ASM ACK work. So it's done. I will load my new file. This one. So technically I can load any. Okay, I don't have anything. Perfect. Sometimes you forget a breakpoint. I just do continue, and I need to go and spirit. So it seems to work. So yeah, it's working. So most likely I've missed something. Sorry, I missed something in the I missed a parameter here to run this. Mm, let's confirm something. 38 4B 2C 38. Like we are able to confirm, we see the exact same bytes here. So this tells me it's my math is good when I did the thing. 08, yeah. It's the okay, wow, that's stupid. Yeah, I loaded the original SLPS. I had to open the other one. Yeah, that's okay. Let's just keep 2865 AC. Yeah, come on, it's already there. Okay, that's better. Now it's loaded. I guess it's a noob error. Yeah. Okay. So that's what I wanted to show you today. This is how you can load some assembly into your game using ARMIPS. Uh, Hope you liked it, and I will do other session probably later this month. If you have any questions, let me know. We also have our Discord server, Super Robot Wars translation. We tried to regroup other translation project. We have a general for 64, but you should use Roboverse translation if you want to have more accurate update. But on our side, this is where we host all the status on Z. If you have any questions or if you want to follow on the topic. Other than that, have a great day, everyone. Bye bye.